welcome. So my name is Cami. I'm a professor here in physics and astronomy, also the director of the Hume Cronin Memorial Observatory, and I'm an Eclipse aficionado. I love eclipses. I want to give you a chance to have a view of what to expect on Monday, April 8th, when a total solar eclipse is happening very, very nearby. And so I'll talk about what a solar eclipse is, what you can expect on Monday, April 8th, where you should go. There's not going to be an event on campus, there's a good reason for that. How to watch it safely, and what to do and what to look for during an eclipse. So we'll start like this, has anybody ever seen the sun? Ever looked at the sun? Okay, that's the first test question. So one of the key things is to actually never look directly at the sun. That's bad. But the sun you see during the daytime gives lots of warmth sometimes. And then there's the moon that you typically see at night, because it's the brightest thing at night. You can also see the moon during the daytime, of course. An eclipse is this weird phenomenon where the sun is out during the daylight, but you don't see it. And the moon is out, not at night, but during the daytime, and it actually, you also don't see it. And so things can get very weird during and before and after totality in an eclipse. So that's kind of what we're talking about. And so the key thing to understand about an eclipse is what's causing an eclipse. Essentially, the moon is orbiting the Earth, and we're familiar, I guess, most of us, with phases of the moon. You go from full moon through last part of the moon to new moon, first part of the moon, and back to a full moon. And the only difference is which part of the moon you actually see. It's always half of the moon that's illuminated by the sun, but which part you get to see depends on where the moon is from our point of view with respect to the sun. It takes about, and this is a number that I'll get back to, it takes about 29.5 days to go from one full moon to the next full moon, or from one new moon to the next new moon. So that cycle of phases, the moon completes about 29.5 days. And so occasionally what happens is that the sun, moon and Earth line up perfectly, and if it's in this configuration where the moon is between the sun and the Earth, you get a solar eclipse. If it's in this configuration where the Earth is between the moon and the sun, the moon disappears in the shadow of the Earth, and then you get a lunar eclipse. And so there's two types of eclipses. A lunar eclipse is the moon disappears in the shadow of the Earth, gets dark, and actually when it's a total lunar eclipse, typically what you see is this copper glow on the moon, and that's now the light of all the sunsets around the planet going through the atmosphere and casting red light on the moon. And a solar eclipse is the moon moving in front of the sun. So if the moon is casting a shadow on the Earth and you happen to be in that shadow, from your point of view, the moon is actually blocking at least part of the sun. In this schematic, you see that the moon is casting a shadow, and there's a very dark, small core shadow that's called the umbra. There's a much larger region around here, denoted by this large red circle, which is called the penumbra. That's the area where the moon covers part of the sun. If you're in this smaller circle, that's where you actually get to see a total eclipse, so there the moon covers the sun completely. What's often wrong in these sort of representations is the scale of things, right? So the moon is about a quarter the size of the Earth, but it's really far away. This is actually the Earth and moon to scale. The moon is far away, it takes about 3 days to get there with our currently fastest rockets to get there. And so because the moon is far away and smaller, it actually casts a small shadow on the Earth. Okay, so the shadow that the moon is casting on the Earth is about roughly 180 kilometers in diameter. Because the moon is orbiting the Earth, the location of that shadow is actually changing. So the moon goes around the Earth with a speed of about 1 kilometers per second, so about 3,600 kilometers per hour. That would also be the speed of the moon's shadow on the surface of the Earth if the Earth was not rotating. The Earth is rotating actually in the same direction. That slows down the pace of that shadow a little bit to about typically 1,800 to 2,000 kilometers per hour. And so there's three types of solar eclipses: a total solar eclipse, a partial solar eclipse, and then there's the type of eclipses where the moon happens to be a little bit further away in its orbit than average, not large enough to cover the sun completely. That's called an annular eclipse. And so it's a fortuitous circumstance that the sun is 400 times larger than the moon, but also 400 times further away than the moon is, and that gives us this possibility to actually get total solar eclipses. So, you have to enjoy total solar eclipses while you can, because this is not going to last forever. Okay? You may not know this, but the moon is moving away from us. Not because of something we said, okay, but it's moving away at a rate of about 3.8 centimeters per year. So that means in the future, we're only going to get annular eclipses because we're going to get to the point that the moon is not large enough to cover the sun entirely anymore. So we have to take solar eclipses while we can. It's only going to be around for another 60 million years or so. Okay. So make sure you get your tests. So if you are in space on the day of an eclipse, this is what the shadow of the eclipse looks like. This actually, it's not the ISS. This is an image taken by the Mir space station, the Russian space station. This is the eclipse of 1999 actually, so I should be in there somewhere in that picture. It was my first eclipse. These days we have satellites looking at the Earth continuously. You may remember in 2017 there was an eclipse. It was a partial eclipse here, but there was a total eclipse over parts of North America. So you see the shadow of the moon racing over the continent quite clearly. So now, if we have a new moon every 29.5 days, roughly every month, why don't we have eclipses every month? And so the answer is that the moon's orbit is tilted with respect to the Earth. And so most of the time, when we have a new moon or a full moon, the moon is a little bit too high or too low. So like in this case, the shadow of the moon goes above the Earth. In other cases, it will be below the Earth. The same on the other side, that the moon will be too high or too low to actually disappear in the shadow of the Earth. And so most of the time you actually don't get an eclipse, you just get a new moon or a full moon. Occasionally things line up perfectly and then you get the conditions for an eclipse. If you look at an image of the Earth's orbit around the Sun, you see we spent quite some time in a configuration like this. No eclipses possible. So what you need to have is a situation like this. So now the intersection of the moon's orbit with the orbital plane of the Earth around the Sun, that's called the known line, that points straight to the Sun. Now you have the right conditions for eclipses, both solar eclipses and lunar eclipses. So the time where the orbit of the moon is aligned properly to get eclipses, we call that eclipse season. Okay? And that lasts 34 days. And 34 days is much longer than 29.5 days it takes to go from a full moon to a full moon. So that means that when we're in the right configuration, you always have at least one lunar eclipse and at least one solar eclipse. You can actually get up to 3 if the first full moon is at the beginning of eclipse season. You will actually have 2 lunar eclipses and 1 solar eclipse. So you can get up to 6 eclipses per year, but you always have at least 2 lunar eclipses and 2 solar eclipses per year. Right? So there you go. If you thought eclipses were rare, they're not that rare. And so just to kind of test out, when was the last lunar eclipse? This weekend, yes. Monday morning, around 3 a.m., there was actually a lunar eclipse. It was not a spectacular one. It was what's called a penumbral eclipse. So the moon gets a little bit dimmer, not very noticeable. And this is actually something you can check, you can fact check, you can verify every time there's a solar eclipse, there's a lunar eclipse 2 weeks before or after. Right? Just because of it. So if eclipses are not that rare, isn't this overhyped, right? You know, like people say this is a once-in-a-lifetime event. Well, so that's an excellent question. Let's look into that. So, eclipses themselves are not rare. Not every eclipse is spectacular, though. Total eclipses are a different thing, and the other thing that you take into account is to see a total eclipse, you need to be in that path of totality, that narrow path. And if you're outside that path, you actually don't get to see anything at all. So, because that path is narrow, it takes, on average, a long time between total eclipses. So, on average, for any spot on Earth, between total eclipses from your location is about 375 years. Okay. And then sometimes it's a bit more, sometimes it's a bit less. So there's a few places in the US that get a total eclipse within, 8 years or something. And then there's other places that haven't had an eclipse for like 2,000 years or so. Okay. So, what about London? So the last time we had a total eclipse visible from London was in 1925. Okay? We have this eclipse, which is not a total eclipse in London. If you miss this one, if you decide I'm not going to go to the path of totality, or I'm just going to sleep in or whatever, if you miss this eclipse and you want to see the next one in London, the next one is going to be October 26, 2144. mark your calendars. So now something interesting to kind of make you appreciate how small that area actually really is. So I've been talking about eclipses a lot in the past weeks. So I was talking to schools in Strathroy and Chatham, and Pauline was talking to a school in Stratford. And so I thought like, oh, it'll be similar. It's not that far away. So this is the path of totality of the 1925 eclipse. Right, and so London was just in the path of totality. Stratford is in the path of totality. Strathroy is not. Chatham is not in that path of totality. So I was like, uh-oh, I need to update that slide for these schools. So I had to kind of figure out, like, when was the last total solar eclipse over Strathroy? And it took a while to figure this out. Also, the next eclipse in 2144, that's visible from London, not visible from Chatham. Visible from Strathroy and Stratford, but not from Chatham. So, it turns out that the last total solar eclipse over Strathroy was in 1451. Okay, so it's been a while. They will get to see the 2144 one. In Chatham, the last eclipse, total eclipse visible was 1806. The next one they'll get to see there is 2444. Okay. So what is rare is to experience a total eclipse essentially from where you live. And so if you miss this total eclipse on April 8th, does that mean you can never in your life ever see a total eclipse again? Well, no, you can, but you have to travel. Next total eclipse after this one is 2026, August 12th, but you have to go to the Arctic, Greenland, Iceland, or you can catch just the last bit of the eclipse in Spain. The next one that I'll go to probably is this one, 2027, over North Africa. The next total eclipse visible in contiguous North America will actually be this one, August 23rd in 2044. And it actually is a very interesting path of totality here near the Arctic. Okay, so that brings us to what to expect on April 8th. So this is an animation of the moon shadow traveling over Canada. So here's London. We're not in that path of totality. And so depending on where you are, you get to see partial eclipse or total eclipse. And you see if you're very close to the edge of the path of totality, the moon shadow covers you very briefly. Whereas if you're near the center line, the entire shadow of the moon has to go over you. So the total phase actually lasts longer the more you are near the center. But what maybe is not obvious is you can only see the splendor of a total eclipse under clear skies. Okay, statistically speaking, the forecasts for around here on April 8th are not great. This is what the current long-term forecast looks like. See, there's the sun. The only thing they get wrong is they put a cloud there, that should really be the moon. So it doesn't look horrible yet, but of course it's still a while out. So keep an eye out on that. In fact, the cloud cover forecast over the entire path of totality that my colleague Peter Brown sent me today doesn't look great, but it's still very, very fun. So suppose that you decide to travel to the path of totality, what can you expect to see? So here's the eclipse experience. The first thing that you notice, if you use proper eye protection, and you should use proper eye protection, the first thing you see is that a bite is taken out of the sun. Okay, and so that's just the moon gliding in front of the sun. And that bite gets bigger and bigger and bigger. Okay, so that less and less of the moon is visible. And if you decide to stay in London, then the reverse happens, and that's it. Interesting, maybe, okay, not super exciting, maybe. Although there's actually a lot of things happening when you have a lot of the sun covered by the moon. A lot of optical effects actually happen that you can see. But to contrast this, if you go to the path of totality, when the moon is completely covering the sun, you get to see the solar corona. That's like a 1,000,000-degree gas, but it's very faint. It's about 1,000,000 times fainter than the sun. So you cannot see the corona on a normal day for two reasons actually. Number one is the sun is too bright, so there's like a contrast issue. But the second thing is you could think like, well, you can just cover the sun, right? And so if you block the sun with something, couldn't you see the corona? Well, it turns out that there's something else that's brighter than the corona, and that's the blue sky. So you also need to switch off scattering by the molecules in the atmosphere. And so you do that by casting a shadow of the moon over where you are. And so that makes a total eclipse the only time where you can really see the corona. I would also say you'll see a lot of pictures like this. These are typically single exposure pictures of the corona during a total phase. That is not how you actually see it. Your eye is a much more fantastic machine than any camera. You have a much larger dynamic range. You typically see streamers much further out with your eye than you see with a single shot camera. Looking at the sun the entire time is a mistake. Okay, during eclipse, you also have to look around you. This is what the sky looks like, where normally the sun is. There's this big black hole in the sky with the corona around. Notice there's a bright spot there. That's actually a planet. Okay, so during this total eclipse, you should also be able to easily see Venus and normally also Jupiter. Looks like it's twilight, and actually during a total eclipse, if you're in an area with clear horizon around you, you'll see twilight 360 degrees around you. Okay, also something that's actually really weird to see and amazing to see. If you look to the southwest, right, the shadow comes from the southwest to the northeast. If you look southwest before totality, you might actually see the shadow go of the moon racing towards you. I've seen it for 1 of 3 eclipses that I saw. Really spectacular how fast that actually is moving. And then this is the corona. This is a picture taken by an amateur in 2001. So I took this and yeah, it's like, okay, I have a picture. And I regretted taking this picture because essentially I spent a long time looking at my camera instead of looking at the eclipse. Okay. This was the least impressive eclipse that I've seen in terms of like there's not much going on in the corona here. But again, this is a single shot exposure. What good photographers do is they take different exposure time pictures and then make these composites. So this is the same eclipse but now done by a professional. This is the inner corona. You also may see something pinkish here. That's actually prominence. That's the other thing that you can see during an eclipse. You actually see the chromosphere, which looks kind of pink. You might see prominences. How much you see in this corona depends on solar activity. Solar activity is nearing a maximum. It has 11-year cycles, and we're very close to solar maximum. In fact, this past Saturday, there were 2 large explosions on the sun, the largest actually in this cycle of activity, that hurled some solar gas towards the Earth and created a big geomagnetic storm with lots of northern lights, while southern lights actually visible from the sea. So you can actually connect this as the same picture as before. You can connect these pictures to what satellites are seeing. So satellites, we have satellites in space that are looking at the sun all the time, but they cannot see the inner corona. So they block out the sun to see the corona, but they cannot really see the inner corona. So this is the only time they can actually connect the inner to the outer part of the corona. People predict what the corona will look like on April 8th. So this was the prediction of this corona on Saturday, actually. And so you see, these things are called streamers in the corona. You see those streamers very far out. So this is a representation of what your eye would actually perceive. How accurate these predictions are, I'm not entirely sure about. So I uploaded the update yesterday, and it doesn't look all that different. Okay, so this may well be what essentially the corona looks like during the total phase. There's another phenomenon called Bailey's beats. So what happens the last seconds before totality, well actually no, the last fraction of seconds before totality, the last sun rays shine through the valleys on the moon. Okay, and so it creates this beaded appearance of light through the moon. I think I saw this once. It's hard to see because it goes really fast, and I think it's almost impossible to see with the unaided, well, without binoculars or something. At the beginning and the end of the total phase, what you see is this phase. It's called a diamond ring, because it looks like a giant friggin' diamond ring in the sky. And this is beautiful. This is a moment where people get emotional. And certainly at the end of the eclipse, right? The sun appears again, you see this diamond ring in the sky, it's so beautiful, you want to keep watching it. But you shouldn't, because this is again direct sunlight, and so you're in the zone again where it can actually do damage to your eyes. So, I can tell you all about eclipses, and that is not necessarily going to convince you that if you go south, you'll actually get to see something unique and awesome. So I thought I'd do something else. So here's a clip. Actually, I wonder whether sound will come through. This is a short clip from the first total eclipse I saw in 1999. There's a little bit of a backstory. I was sent on behalf of the European Space Agency to Hungary to do measurements, essentially take pictures of the sun through an H-alpha filter. And my French colleague Ludovic was also sent on behalf of the European Space Agency to take images in white light from the same location. Unfortunately for him, about 2 minutes before totality, his computer crashed. And he did not manage to actually reboot it in time for totality. So this is the cleaned up version in terms of audio. Because there's subtle French, not so kind words about starting this computer. So if you hear silence, you know what actually really happened, right? Oh, I have to probably change the sound. Let's see if this works.
But this is great.
Wow, man, look at all those streamers. I mean, you can see up to two or three
This
ranges.
is really great.
You see these streamers? It's incredible. It's amazing.
Wow.
It's already...
I can't believe this. I cannot believe this.
You see that's your pose.
Yeah, look. Wow.
Make the second one shorter, yeah. 30 seconds. Yes. Wow.
Wow.
Did you see it through a telescope? You should
eclipse totality lasted 2 minutes and 21 seconds, which if you see it on the screen now, actually looks very long. When you're experiencing it, it's over before you know it. Okay, so lots of things are going on. So if you look only at the sun in the sky, you're actually missing out on a lot of really cool things. So before totality, already optical things change around you. Okay, so you will notice, even if you would stay in London, which nobody will do, right? Even if you're here, you'll actually start noticing as more and more the sun gets covered, things look off. You kind of look around you and you see the world, you recognize things in the world, but there's something off and you can't quite put your finger on what it really is. So the light becomes very pale and you perceive colors differently, but the other thing that's happening is you start losing ambient light. The sun, instead of being nice and round, becomes essentially like a long slit, and it changes shadows. And so here's a movie demonstrating the difference in shadows. And so what you'll see during totality is that some shadows are actually much sharper aligned. And so everywhere around you is full of shadows. You just don't realize that some of those are sharp, and that makes that kind of screws your mind. So here's
My arm is in line with the crescent sun, about a 50% crescent phase right now, and the shadows cast by my arm are sharp. Now I'm going to change my arm to be perpendicular to the crescent. And you see how there's a double shadow now? It's fuzzy because my arm is causing an umbra penumbra.
My experimental model has two bars, a perpendicular bar creating a fuzzy shadow and an inline bar creating a sharp shadow at the same time.
okay. So those things you don't necessarily perceive as such. Now you know, maybe you do, but the first time I was like, I don't know what it is. I couldn't really describe what's going on, but this is essentially what's happening.
My arm is in line with
The other thing to do is, so I don't think you should look at the sun all the time, even if you have protective eyewear. Typically, you look for a few seconds, kind of see how things have been progressing, and then look around you. Look at what's happening in nature around you. It's maybe not the right time of year, but in previous eclipses, I've seen flowers close during totality. Animals will respond, and also look to see that shadow cone of the moon. There's also very, more rare effects that you can look for. And the movie I'll show now starts about a minute or so before totality, and it shows shadow bands. And shadow bands I have always looked for the 3 total eclipses I've seen. I've only seen it once. And that was essentially on the doors of our van. And shadow bands are like fleeting shadows. You'll see it on the road here in this movie. It's hard to see. It's a very low contrast thing. We don't understand very well what is causing them. It's probably related to do with refraction in the atmosphere. Maybe the same reason why stars twinkle. But it's something hard to see. The other thing to take home from this picture, this is how the light is changing in the last minute before totality. Okay, and so at the start of this movie clip, that's about the light you'll get in London. It'll get a bit dark in London. Something I guess it'll be more like say severe thunderstorm type dark, not night time dark. Okay, so that's about a minute or so before totality. So I don't know how well you can see it, but there's see these fleeting shadows over the road here. And then it gets darker. Not at totality yet. Now we're at totality. You also noticed how the mountains in the back disappeared suddenly. Okay, so that goes fast. It's that last little bit, and so I often say that the last ray of sunlight that's being blocked by the moon quite literally makes a difference between night and day, and it's not really the last sun ray, but it's really the last 30 seconds or so that make the biggest difference. I got a lot of questions about taking pictures of the eclipse. Can you take pictures of the eclipse? Yes, you can, but do so at your own risk. And I say this because in 2017, I got to see probably something like 20 or 30 pictures of people, amateur photographers, that decided, like, I don't have the proper equipment to take pictures of this eclipse. So they went to rent, like, a reflex camera with, like, a large telephoto lens. And they're like, well, we're going to be smart about it. I know, sun is dangerous, so we're not going to take pictures during the partial phase, only during the total phase. So what do you think happened? They point their big telephoto lens to the sun, thinking everything is safe. You collect all the sunlight and you focus it on the shutter, and they burned through the shutter and then through the chip. And so they lost a lot of money and had 0 pictures. So it's something that you can do. If you have never seen a total eclipse, my advice is to actually not bother, because you lose a lot of time actually looking at your camera. And I've done it in 2001, and essentially I lost half of the eclipse in my mind, right? So I have a new camera now that I can pre-program. So I have a whole series of exposures pre-programmed. All I have to do is press one button at the beginning of totality, and then I'm not going to look at it anymore, right? And, you can also use a cell phone camera. With a cell phone camera, I would not spend too much time pointing at the sun before totality. If you want to take a picture of totality with your cell phone, the biggest mistake you can make is try to zoom in. Okay, don't do that. There will be lots of issues with autofocus, so you might have to kind of focus yourself and change the brightness yourself. But it is possible. I've seen pictures like it. Some of the amazing pictures you see from photographers, if you want to get an idea of how that works. This is a short clip from Fred Espenak. He's also known as Mr. Eclipse. He worked for NASA, and for NASA he made essentially all the predictions for solar and lunar eclipses. So any predictions you've ever encountered in your life, he most likely actually made. He wrote books about photographing eclipses. So his setup consists out of something like 7 different cameras, telescopes, and that sort of things. And he has a script that he follows, and he starts practicing about a month before the eclipse. Okay? And he has like several timers to make sure that he knows at which mode he has to switch to one or what. So I just thought I'd play it so you hear how professional experience is a total eclipse. This is starting 45 seconds before totality.
Telescope filters off. 50 seconds. Shadow to the northwest. 30 seconds. 25. Corona.
There's Venus.
Venus. Bailey's beads. Totality.
Look to your camera, Jeff. There's a prominence at 3 o'clock. You might be able to see it right there at mine, but I can't see it on the camera. You see it? A little pink thing? See Mercury?
30 seconds.
Look at the horizon. Look at the horizon.
25 seconds. Oh, look how bright it's getting. Look at the shape of the shadow cone.
You see it? See it? See that V over there?
15 seconds. Chromosphere. 10 seconds.
Chromosphere. 5 o'clock. See that shape? Oh my God, here it comes.
Here it comes. Beads. Bailey's beads.
Take pictures, take pictures. Woo!
So for some reason, people that take movies of total eclipses get excited. So let's now look at our local conditions. So this is for April 8th, the path of totality. So the blue is the center line. That's where you get the longest eclipse. This is the northern edge, the southern edge. And so you see London is right here. It's not in the path of totality. And so if you stay in London, you're not going to experience a total eclipse. You will see a partial solar eclipse. If you go to St. Thomas, normally in St. Thomas you get 25% more. You're not going to get 25% more of a partial eclipse. You're actually going to get like a full total solar eclipse. But it's fairly close to the edge of the path of totality. So if you're in the north part of St. Thomas, you'll get about 1 minute totality. If you're in the south of St. Thomas, about 1 minute 30. If you would go further to Port Stanley, you'll get about 2 minutes. Port Burwell, almost 3 minutes. And if you find a way to get all the way to Long Point, that will be the longest totality in this local area. That's about 3 minutes and 43 seconds of totality. Okay. So if you're in London and you stay in London, it's been advertised as a 99.6% partial eclipse. I think that's false advertising. It's really a 0% total eclipse. Okay. So this is what the London sky will look like at maximum eclipse. Even if you stay here, you should actually be able to see Venus. Okay. Actually, you can see Venus every day of the year in broad daylight, if you know where it is. It's Venus is that bright. On top is Jupiter. Jupiter from here, I think, will be a lot harder to see. And if you would look close at the sun, well, you won't really see much. You have to keep your glasses on. There's a thin sliver of sunlight left right there. St. Thomas, on the other hand, you will get to see the corona. That's also the part when you're in the path of totality, and only if you're in the path of totality, and only while you're during the total phase, you want to remove any eclipse glasses you have. Because this is much fainter than the sun, and so if you wear eclipse glasses during totality, you're going to see nothing at all. Okay? So in St. Thomas or in the path of totality, it's going to be noticeably darker. You might actually be able to see Saturn and Mars as well. Mercury should be closer to the sun. If you have binoculars, there's also a comet in the sky, comet Pons-Brooks. It's 4th magnitude. It's going to be right next to Jupiter. It's probably too faint to see with the unaided eye, but if you have good binoculars, you might actually be able to spot it. So, what sort of things to do, what to look for during the eclipse? And so here's the first warning. You should never ever look directly at the sun without proper protection. You have a lens in your eye. If you look at the sun, that lens focuses the sunlight onto your retina. And if you've ever played with a magnifying glass, you know you can set things on fire with the sun. Well, your lens in your eye can do exactly the same thing, so it will burn your retina. And unfortunately, you have no pain receptors in your eye, so you don't feel a thing. So you're doing enormous damage to your eye, and you think everything is fine. And so in '99, the first eclipse I saw, one of the stories that I remember is 2 German teenagers that had a wager going on for a couple of beers to see who could look into the sun the longest directly. So they looked at the sun and were like, oh, no, it's only very bright, and then for the rest of their life, that's all they saw was bright stuff. Right? So don't do that. So what you want is, there's a few things you can actually use during the eclipse. The number one thing to use is eclipse glasses. Everybody have eclipse glasses yet? No? Who would like some? Okay, I'm going to sell them for $1 million. No, we're giving them away for free, of course. So there's a lot of different types of glasses that are being made. The ones that we have come from one of the largest American suppliers that actually sends the glasses for inspection to laboratories, so they're properly ISO certified. You can easily test whether the glasses that you have are good or not if you bought them online. Indoors, you look around, you should see nothing. Okay? If you look at a very bright light from nearby, you should faintly see it. I actually tried this out with my cell phone light. If I hold it here, I can faintly see it through these eclipse glasses. Okay? If you go outside, you should only see the sun or the sun reflecting off bright surfaces. If there's any scratches on these, if there's any punctures in these lenses, throw them out because they're not safe to use. If you have these glasses and the eclipse is over, don't throw them out either. You can use this on any sunny day. And as I mentioned, we're nearing solar maximum. So that means there's actually quite a few days where there's large sunspot groups on the sun that you can just see with these eclipse glasses. Okay. So yeah, that's I mentioned. So if you stay in London, how to observe a partial solar eclipse? Well, every time you look at the sun, you use these glasses. Okay? There's no time here in London where you should take these glasses off. During total eclipse, during totality, you want to remove these glasses. Okay, and they should go without saying. You only need these glasses when you look at the sun. If you look around you, you don't need to wear these glasses. As they issued a warning in Misery to motorists, don't drive a car wearing these glasses. Not safe to do so. That's not the only way that you can actually look at the eclipse. You can also make a pinhole camera. It's fairly easy. You take a push pin or something, make a small hole in a piece of paper. Now with the sun to your back, you can hold the paper here, second page here, and you project the sun through that hole onto the second piece of paper, and now you actually see how the eclipse is progressing. That's the easiest way to make a pinhole projector. You can build it into a box as well. That makes the contrast a little bit better, so that's easier to see. There's a lot of different ways of actually building one. If you have kids and you're looking for activities to do with your kids, you can have them push out their name or something with little holes on a piece of paper. They are doing totality. You see that what's projected here is not just little circles, it's always a little piece, it's a projection of the solar crescent now, right? And so they can take a picture of that and you have a souvenir of the eclipse. Then this is also something fun to try. So this piece of paper has 3 different geometric shapes in there. On a normal day it'll look like this. It will be very hard to distinguish the shapes. Shortly before and after totality, when the sun is small enough, actually these shadows will appear quite sharp. There's lots of things to do. You can keep track of how fast the moon is moving, right? It's 3,600 kilometers per hour, but you really see over time that the moon is moving one diameter in about an hour, right? So you actually see that quite clearly. Drawing the sun shape every 15 minutes will give you a good idea of how quickly things are progressing. Is it actually getting darker? How dark is it getting? Do you see the shadow cover of the moon? Do you see kind of this twilight all around you? In many cases, it also gets a little bit colder, like temperature drop of a few degrees. Depending on where you are, depending on where it's an open field, you might also actually feel a breeze coming up. I've had that for 2 of the 3 eclipses as well. What's very annoying is streetlights turning on. Okay? Nothing as annoying during totality. If you make sure that your eyes are dark adapted by them, suddenly all the streetlights come on. Okay? People with flashes, also very annoying during totality. So one thing you can do if you pick your spot to watch totality from, pick somewhere where streetlights are not going to be an issue. Look for animals. Animals respond to this. The most noticeable that I've had was in Africa in 2001, where 5 minutes before totality, mosquitoes came out by the millions. And then a little bit later, the bats came out to eat the mosquitoes, and the hippos came out of the river to graze because they did it in twilight normally. And then a bit later, like, oh, what's going on? But birds might respond to this, so maybe it's too early for the bullfrogs or so. And yeah, shadow bands, planets, and stars. So lots of things that are going on during eclipse. And so you should be safe and have fun. You can use anything that has holes as pinhole projector, pinhole camera. One of the most popular things to use is a colander, because all the holes make nice solar projections. But really, anything with holes, with small holes works, even like a Ritz cracker, if you can avoid the temptation to eat it. Also, outside, if you're near trees, the sunlight through the canopy of trees creates all these projections. It's a bit early in the year, so there's not going to be a lot of trees with lots of leaves, but maybe you find some evergreens or something. If you find yourself completely alone without any tools and like, oh my god, I wish I had like something with like a small hole, and you can just use your hand as well and make a projection of the solar crescent. So whatever you do, be safe. Make sure you know what to do and where to go, and try to be in that path of totality and be amazed by this spectacle. Thank you. And any questions other than can I get a pair of Eclipse?
Can we have your slides?
Sure. I have them on a Dropbox somewhere. They're like 500 megabytes or so.
Just a PDF?
Oh, I can make PDF, yeah.
But you should tell about the website. You sent that to me because because you can get the path of totality and you can click on any spot there and it tells you how long it's going to last.
So the top QR code goes to the Eclipse page that we made at Cronin. That has lots of information, lots of links. The second one is Western Space Eclipse page. This brings you to an interactive Google map that has a path of totality for this eclipse. It's a bit slow to load sometimes, but you can zoom into whatever place you will be at and click on it, and it will tell you how long totality will last and what the exact time is. There's lots more information on
What's the time on that map? Because it's like 1,800 hours. Is that Greenwich Mean Time or something like that?
That's, yes, universal time. So you have to subtract 3-4 hours or something, I think. I mean, so all around here, the total, it starts at around 2 p.m. with the partial phase. The maximum is going to be around 3:17, 3:18, and it will be over by 4:30. And that's for like Sagas. It's a few minutes difference with like Montreal. So it's this one. Good, good. I mean,
Receivers, they have a
I just in my house.